In this video, we learn how to solve a pair of simultaneous equations using the method of elimination, also called the elimination method. And this is the first of two videos, and in this one, we're going to solve the pair of simultaneous equations that we see here. Now, in just a minute, we're going to be learning a three-step method that we can always use to solve simultaneous equations using the elimination method. But before we do anything, we should always label or name our equations. Here's what I mean. I'll call this first equation E1, and I'll write that on the far right-hand side here. There we go. That's E1, as in equation 1. And I'll call the second equation E2, as in equation 2. Okay, now the whole idea behind the elimination method is to combine the two equations we have in such a way that we eliminate one of the two unknowns. So in this case, either x or y. So let's say we decide that we're going to eliminate the y's from these equations. And I should say we could choose to eliminate the x's from these equations. It would lead to the same result in the end. But initially, I'll go ahead and choose to eliminate the y's. In which case, my first step, step 1, will be to make sure I have the same number of y's. And so I'll write make sure we have same number of y's in both of the equations. So I'll say in E1 and E2. I'll add here that had we chosen to eliminate the x's, then we'd have to make sure we have the same number of x's in both of the equations. Okay, now let's take care of this first step. In this first equation, E1, we only have one y. Indeed, although we don't write it, when we have a y written this way, it means 1 times y. On the other hand, in the second equation, E2, we have 3 y's. And to make sure we have the same number of y's in both of our equations, we can go ahead and multiply the first equation by 3. And in fact, I'll write what we'll do underneath here, so I'll say 3 times the first equation. There we go. Okay, well, multiplying this entire equation by 3, we'll have 3 times 2x, which is 6x. And so I'll write that here. We'll have 6x plus 3 times 1y, well, that will be 3y. And on the right-hand side, we'll have 3 times 4, which is 12. And that's our new equation 1. Our equation 2, of course, doesn't change at all. So we'll have negative 4x plus 3y equals to 2. That's equation 2. And that's step 1 done. We can now see that both of the equations we have the same number of y's. So we move on to step 2. And in step 2, we combine the two equations we have by either adding them together or subtracting one from the other to make sure that we eliminate the unknown we chose. So in this case, we need to make sure that we eliminate y. And once that's done, we'll be able to find the value of the other unknown. And so here for step 2, I'll say combine E1 and E2 to eliminate y and solve for x. Okay, well, as I just said, when I say combine the two equations, it either means adding them together or subtracting one from the other. And looking at what we have here, we notice that in both of the equations, the 3 y's are being added. And as a rule, if they're both being added or if they're both being subtracted, then we'll subtract one equation from the other to eliminate the unknown. And here's how to do that. I'll go ahead and subtract E2 from E1. But if you want, you could subtract E1 from E2. It doesn't matter, both would work. And so I always keep track of what I do, so I'll write E1 minus E2. There we go. Okay, so let's see. Subtracting this second equation from the first, we'll have 6x minus negative 4x. And in fact, I'll write that out. I'll have 6x minus negative 4x plus 3y minus 3y. Well, 3y minus 3y, well, that's 0y, which is just 0. And so I won't bother writing that. And so that will equal to the difference of the right-hand sides, which will be 12 minus 2, which is 10. Notice that at this stage, we've just gone from having two equations with two unknowns to one single equation with just one unknown. So we can solve this. Indeed, carrying on here, 6x minus negative 4x turns into 6x plus 4x, and that's still equal to 10. And now 6x plus 4x is 10x, and so we have 10x equals to 10. Finally, carrying on over here, since x is being multiplied by 10 here, to find what x is, we can divide both sides by 10, which quickly leads us to x equals to 10 divided by 10, which is 1. And we now have the unknown x. And that's step 2 done. So I move on to the third and final step, step 3, in which I use the result we just found, so x equals to 1, with either one of the two equations, e1 or e2, to find the second unknown y. So I'll go ahead and say use result. And so I'll just say use result x equals to 1 with either of the two equations, e1 or e2, to find y. Okay, well, let's see. I'll go ahead and choose to use e1, but let me insist I could use e2. It doesn't matter. But so using e1 with x equals to 1, this equation turns into 2 times 1 instead of 2 times x. And so I'll write that. That's 2 times 1 plus 1y, so plus y, equals to 4. Carrying on, that's 2 plus y equals to 4. And finally, getting rid of this 2 that's being added to the left-hand side by subtracting 2 from both sides, we quickly find that y is equal to 2. And we're done. We now have the second unknown. And so the solution to this pair of simultaneous equations is x equals to 1 and y equals to 2. And we could check that, of course. Indeed, if we replace x by 1 and y by 2 inside this first equation, we'll have 2 times 1, which is 2, plus 2, which indeed is 4. And in the second equation, replacing x by 1 and y by 2, we'll have negative 4 times 1, which is negative 4, plus 3 times 2, which is 6. And so negative 4 plus 6, well, that gives us 2. So these are definitely the correct solutions. Okay, as such, that's this video done. So if you want, you can stop watching there. But I would encourage you to keep on watching. Right now, we've just solved this with a 3-step method in which we chose to eliminate the y's. And in fact, I'll write that here. In that first step we made, we chose to eliminate y. But as I said when I wrote down this first step, we could have also chosen to eliminate the x's from these equations. And so if you keep on watching, you'll see how I could have done that. So let's go. My starting point would of course be the same. I'll have the two equations 2x plus y equals to 4. That would be my equation 1. And my equation 2, or second equation, would be negative 4x plus 3y equals to 2. That's equation 2. Again, I'll solve this with the 3-step method we just wrote, but this time I'll eliminate the x's. And so consequently, in step 1, I need to make sure that I have as many x's in both of these equations. Looking at these, we quickly see that equation 1 has 2 x's and equation 2 has 4 of them. And so to make sure that both equations have the same number of x's, we could multiply this entire first equation by 2, since this 2x would then turn into 4x. So let's go ahead and do that. As always, I keep track of what I do, so I'll say 2 times equation 1. Well, let's see, we'll have 2 times 2x, which is 4x, plus 2 times y, so that will be 2y. So I'll have 4x plus 2y, that's the left-hand side taken care of, and that will equal to 2 times the right-hand side, so that's 2 times 4, which would be 8. And that's our new equation 1. Equation 2, well, that stays the same. That's still negative 4x plus 3y equals to 2. There we go. And now that we have as many x's in both of the equations, that's step 1 taken care of. And so we can move on to step 2. And I'll write that at the top of the page here. There we go. In step 2, remember, we need to combine the two equations to eliminate the unknown we chose. So in this case, to eliminate x. Now in this case, if I subtract one equation from the other, well, it won't eliminate the x's. Indeed, if I did e1 minus e2, it would be 4x minus negative 4x, which would be 8x. And if I did e2 minus e1, well, that would be negative 4x minus 4x, which would be negative 8x. On the other hand, if I were to add these two equations together, then we'd have 4x plus negative 4x, or 4x minus 4x, which leaves us with 0x. In other words, that eliminates the x's. So to combine these two equations in such a way that we eliminate the x's, we'll go ahead and find e1 plus e2. And quickly remembering what I said earlier on when we eliminated the y's, if the sign in front of the unknowns we're trying to eliminate is the same, then we'll subtract one equation from the other. But if their signs are opposite, as they are here, we have positive 4 and negative 4, then we'll add the two equations together to eliminate the unknown. Back to this. Adding e1 to e2 will have 4x plus negative 4x, which is the same as 4x minus 4x, which is 0, so I don't write anything there. And we'll have 2y plus 3y. And 2y plus 3y, well, that's 5y. And that will equal to the sum of the right-hand side, so that's 8 plus 2, which is 10. Now to find what y is equal to, we get rid of this 5, which is multiplying the y, and we therefore do so by dividing both sides by 5, and that leads us to y equals to 10 divided by 5, which is 2. And that's y found. Notice that that's the same result as we had found previously, and that's just as it should be. Now that we've found y, we move on to the third and final step, step 3, in which we use the result we just found, as well as either one of the two equations we started off with, to find the other unknown, in this case x. Well, let's see again. I think I'll use the first equation, e1, and so I'll say e1 with y equals to 2. There we go. Okay, so copying this first equation but replacing the y that we have by the value we just found, 2, it turns into 2x plus 2 equals to 4. We now need to solve this equation for x, and to do that I'll start by getting rid of this 2 that's being added on the left-hand side, and I do that by subtracting 2 from both sides of the equation. So that's 2x equals to 4 minus 2, which is 2. And finally, I get rid of this 2 that's multiplying the x on the left-hand side, which I do by dividing both sides of the equation by 2. And finally, we can state that x is equal to 2 divided by 2, which is 1. And we're done. We've just solved this pair of simultaneous equations by eliminating x. And there we have it. These 3 steps can always be used to solve simultaneous equations using the elimination method. And in fact, in the next video on this topic, I solve a slightly more complicated pair of simultaneous equations using the same 3 steps. So do make sure to watch it. Until then, that's it for this tutorial.